So in this video, I'm going to explain you how to expand ex as of infinite series. So first of all, we are taking this fx as ex. So we try to differentiate this. So if you differentiate this one, we get ex. Again, if we differentiate, we get ex. So if we go on doing till the nth derivatives of this, we get nothing but ex. So this shows that fx possesses derivatives of every order for every value of x. Okay, now we'll try to find fn of 0. So it is e to the power 0, which is equal to 1, and the remainder, we are taking the remainder in Lagrange form. So we have rn x to the power n by n factorial fn theta x 0 is less than theta is less than 1. So if we put here theta x, we get here xn by n factorial e theta x, where 0 is less than theta is less than 1. Then we try to write the Malkourian theorem for a finite series. So we have this Malkourian theorem. So here it is fx equal to f0 plus x f dash 0 plus x squared by 2 factorial f double dash 0 plus dot plus x to the power n minus 1 by n minus 1 factorial f of n minus 1 0 plus x to the power n by n factorial fn theta x 0 is less than theta is less than 1. So this is the Malkourian theorem for finite series, which we have done already before. So fx is nothing but ex, we are substituting, and if we put here every 0, in any cases we get all 1. So we are getting here 1. Okay, so we are getting every time 1. So here we have what? F of 0 is 1. Okay, we are getting here f of 0 to be 1, and x f dot 0 is also x, plus x squared by 2 factorial plus so on, plus x to the power n minus 1 by n minus 1 factorial plus x to the power n by n factorial e theta x, where 0 is less than theta is less than 1. So this is a finite series Malkourian theorem. Now we consider an infinite series corresponding to the above finite series. So in place of this fn theta x, here we have taken fn theta x, we assume that it will be fn 0, so that is equal to 1. So this infinite series will become as 1 plus x squared by 2 factorial plus plus x to the power n minus 1 by n minus 1 factorial plus, here see we have taken as theta x, here now I'm taking as 0, so e0 is nothing but 1. So we get xn by n factorial plus . Now we have to show that this series is converging. Okay, so to show that this series converges, we are using the ratio test, which you are going to learn in unit 3. So the ratio test, I'm assuming the ratio test to be this. So un plus 2x by un plus 1. So means the n plus 2 term of this series. So the n plus 2 term of this series is nothing but it is x n plus 1 divided by n plus 1 factorial. And the n plus 1 term of this series is x to the power n by n factorial. So we have this, so x to the power n plus 1 by n plus 1 factorial by x to the power n by n factorial. So this divide, I've changed to multiplication, so this go up. So x to the power n plus 1 can be written as x to the power n into x. So here I'm writing x to the power n into x, and n plus 1 factorial also can be written as n factorial into n plus 1, or we can write n plus 1 into n factorial. So here we have n factorial into n plus 1. So n factorial and n factorial get cancelled, x to the power n and x to the power n cancel, so we are left with x by n plus 1. Now, since as n tends to infinity, this become bigger and bigger, so this will approach to infinity. So anything by infinity will be up. If this become bigger and bigger, the whole thing will become smaller and smaller. So this fraction will become smaller and smaller, and finally it will approach to 0. So that's why we get the limit of this as n tends to infinity is nothing but 0. Now if this value in ratio test, if this value is less than 1, then it converges for, and if this value is greater than 1, then it diverges. But here we got 0, so 0 is less than 1, so it converges for all value of x. So hence the above series, infinite series, converges for all value of x by ratio test. Now only our aim is to show that the remainder tends to 0 as n tends to infinity. So here we must prove, now we'll prove this, Rn tends to 0 as n tends to infinity. Now if we look this one, e theta x, where 0 is less than theta is less than 1, this is lying between 0 and e to the power 0 is 1. So it is lying between 0, it is lying between 1 and ex for every value of x. So since the value is lying between 1 and ex, that shows that it is bounded. And also if you see this, x to the power n by n factorial, okay, if you apply the limit n tends to infinity, if you compare this one x become bigger faster compared to this. So as this become bigger faster, so this whole thing will approach to 0. So as n tends to infinity, so this thing is 0. Now if this is 0, now you are applying the limit n tends to infinity both sides. So if this is approaching to 0, this is bounded. So 0 into bounded function will be always 0. So we get that the remainder tends to 0 as n tends to infinity. Since we have shown that remainder tends to 0 as n tends to infinity, then we can show that we can use the Markov infinite series, and we get as ex equal to 1 plus x squared by 2 factorial plus plus xn by n factorial plus so on. So and we can show that this converges for all value of x. Thank you.